Okay, good evening, students. We are going to discuss today MCQs from 11 to 20 in our unit test for the first unit. From the first unit, we have some good questions actually in this paper. So I hope you all got your marks also. And more importantly, it's okay to get wrong and everything because there is enough time for you to do mistakes and learn from them. My point is write a good review for every mistake you did, especially mention about why you got wrong, and especially mention what is the correct method to approach the answer. Like that, write a good review. Then take some time about the MCQs you got correct answers also. Let's say you got 15 correct and 5 questions are wrong. You have to focus more on that 5 questions. Okay, and write a good review for them. For the remaining 15 MCQs also, which you got correct, you have to write something about that. Okay, so maybe the method you approach the answer, or you can write why other statements are wrong. Like that, write something. So sometimes these facts you already know, but anyway, keep writing that one and keep referring those recordings and reviews again. Okay, so which will sharp your knowledge about the first unit. Okay, you have to have a crystal clear idea regarding first 3 units because it is the foundation. Without a good foundation, we can't build a good house. Okay, you know that, right? So therefore, the other lessons are kind of easy if you master these 3 units: first unit, second unit, and the third one. So we finished the first unit, which is atomic structure. Okay, now we are in the second unit, bonding. Okay, and from a part of the third unit also I did parallel to the first unit. Anyway, in upcoming classes, not this week, from the next week, I'll be reminding you the theories we did from the unit 3, chemical calculations. We did several theories. So I'm going to revise them once again in our theory class. And then from next week, we are discussing the structured essay paper. After that, again, this practice paper thing will be resumed. So for those papers, I'll add questions from unit 1, unit 3, and the things we did from the unit 2 also. Maybe the beginning of September, we will be keeping our next test. It will be kind of a term test like thing, and it is a compulsory one for each one of you, and you have to come and write the paper. And that paper will be including the first 3 units, evaluation test 1, right? Okay, now let's discuss the paper here. 11th question. The total number of electrons that satisfy the condition N plus L equals to 4 in a ground state, iron 3 plus iron. Okay, ferric iron. Okay, so first of all, in a question like this, we need the electronic configuration of iron 3. Okay, before coming to iron 3 plus electronic configuration, just think about the electronic configuration of the atom before you go to the iron. Okay, so Fe, electronic configuration, we need to write. Before starting that, we need the how many electrons are there in the iron. Okay, so how many electrons are there, we can get that one from the atomic number of Fe. Its atomic number is 26. So how do we know that one? Because you are getting a periodic table for the test. Okay, so a small one. I hope you all have that one with you now. You can refer that and find the find the atomic number. Okay, so it's 26. That means there are 26 electrons for this neutral atom. So this is the electronic configuration: 1s2, 2s2, 2p6, 3s2, 3p6, 3d6, and 4s2. So how did I write that one quickly? Because we learned a theory, okay, it was discussed in previous classes also, that if it is having 26, okay, that last number will come as the number of d electrons. Okay, so there are 26 electrons, so the electronic configuration will be like this: 3d6, 4s2, right? So the reason for writing 4s2 outside, even though it is filled before 3d, okay, because when ions are formed, cations are formed, electrons are removed. So when that removal happens, it is happening from the last sub-energy level, which is 4s here. Understand? That's why we write 4s outside. Okay. So to get in Fe3 plus, you need to remove 3 electrons. Those 3 electrons are removing from the outermost sub-energy level first. That means first of all, you need to remove this 4s2 electrons. Okay, then you need to remove another electron. That should be removed from where? We have to remove it from 3D. Okay, so then electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p6, and 3d5. 3d5. Understood? You have to remove 3 electrons. You are removing that from 4s and 3d. Okay, so it's very important to write electronic configuration of the atom in this way. If you write this accidentally 4s2 3d6, then sometimes you might think to remove electrons from here. That will give you a false answer. Understood? So therefore, write the configuration as I ask you to write. Okay, writing this way is not wrong, right? But in the questions like this, you might face a trouble. Okay. So, however, now we have the electronic configuration of iron 3 ion. So, yeah, iron 3 ions. We are writing it like IRON and ION ion. So, it's kind of confusing to tell. So, let's say this is ferric. That's how I use here on. It is ferric ion. Ferric ion. Okay. So, this is the electronic configuration of ferric ion. So, now we need to find how many electrons, I hope they ask, yeah, how many electrons that satisfy this condition, n plus L equal to 4. So what are these letters, N and L? So those letters are quantum numbers. Okay, quantum numbers means it is coming from the newest theory about the atom, atomic model, quantum atomic model. Okay, so location of electron can be expressed by using these 4 quantum numbers. Okay, right? So N, L, ML, and MS. Okay. So N represents main energy level. Okay, it is called as principal quantum number, and L represents sub energy level. It is called as the azimuthal quantum number. Okay, so by these things, this electronic configuration, we can get the idea regarding the N and L values. Okay, so let's write what is the N values for these sub energy levels. You can think and write also, but anyway, I'm giving you something to add to your reading. Okay, so n values here, the n value is 1, 2, 2, 3, 3, and 3. These are the n values. Okay, so then the L values you can write. Now here's the tricky part. So n value represent main energy level, I forgot to mention. So I write 2 here because it is in the second energy level. That's the principal thing. Okay, normal thing, right? And then L sub L represents sub energy level. There are several sub energy levels. We have S, P, D. Okay, so L value for the S is 0, for P it is 1, for D it is 2. Okay, so like that, here the L value for the S should be 0, 0, 1, 0, 1, and 2. Understood? So now what we have to do, we have to add these N and L values together. Okay, so now let's take N and L. So it is a nice way to write like this. Okay, so what are the additions here? It is 1, 2, 3, 3. Still we didn't get our condition. We have to find how many electrons that fulfill this 4. Okay, and here now we have 4, and then we have 5 with this one. Now this is the these are the electrons that satisfy our condition, 3p6. Okay, 3p6. So these 6 electrons are satisfying our condition, n plus L equal to 4. Understood? So it's asking how many electrons are there. So this condition is satisfied by 6 electrons, which are there in where? 3p6. Understood, Lama? So our answer should be answer 1. Answer 1. Yeah, question number 12 to 16, we have ABCD questions. Okay. So what I saw in your papers, most of you did really well with the ABCD questions and the last question, the true false question. Okay, which of the following statement or statements regarding electromagnetic spectrum are incorrect? Okay, electromagnetic spectrum. So there are 4 statements given. There are several regions in electromagnetic spectrum, and they all differ from one another because of the wavelength and the frequency. Okay, so the order I said earlier is the increasing order of the frequency, and they all have the same speed in a given medium. Those are some basic points regarding electromagnetic radiation, which you might have learned from the O-levels, right? So why did we learn electromagnetic radiation for our first unit? Because we had a topic called Bohr model. Remember, in Bohr model is used to explain hydrogen emission spectrum. That's why we learned the electromagnetic spectrum. So it's asking, several statements are given. First one, energy of a photon of an electromagnetic radiation always gives a constant value when divided by its frequency. It's a really good statement, okay? Energy of a photon of electromagnetic radiation. So electromagnetic radiation is a collection of energy packets, no? So we call it as photon. Photon, particle of energy, photon. Remember, Einstein gave this name. So energy of one photon is equal to A equal h nu. Nu is frequency, h is Planck constant, and this is energy, right? So what the statement is telling? Energy of photon of a given electromagnetic radiation always gives a constant when divided by its frequency. That means the A statement is telling divide the energy of one photon by its frequency. Then they are telling it is giving a constant. So we have to check whether that is true, isn't it? So that is actually true. Okay, what is this constant? If you just get E over nu from this one, you are getting the Planck constant. So that statement is then correct because we are getting the Planck constant. Okay, so energy divided by its frequency, you get the Planck constant. So we have to figure out that. I know all of you know this formula. Okay, there is no one who doesn't know this, right? Everyone know this one, but see how many of you got the statement correct. Okay, so that's the problem. Okay, you have to think like that. So start that one even from our very first paper. Okay, so you all can get really improved. Okay, so that's the first thing that is correct, and it actually gives a constant, which is the Planck constant. Okay, Planck constant. Right, then look at the second one. Frequency of electromagnetic radiation of wavelength 400 nanometer. Okay, so 400 nanometer wave is there, is higher than the frequency of the electromagnetic radiation with 700 nanometer. There is another one with 700 nanometer wavelength. 700 nanometer. So what we know, when the wavelength increases, wavelength lambda increases, your frequency should decrease. Why? Because the product of these two is equal to a constant, which is the speed of light. Understand? So when one increases, other one should decrease because those are inversely proportional. Inversely proportional. The 400 nanometer wavelength, now here the frequency will be higher and here the frequency will be lower, isn't it? If the wavelength is lower, frequency should be higher, like I said. So the B statement is true. Okay, B statement is true. So be careful here, okay, Lama? So did they ask for the correct statements? No, they are asking for the incorrect statement. So don't forget about that one. I saw some of you selected the correct one also. You have to read the questions carefully. Okay, so A and B are correct, but they are asking the incorrect ones. Okay, so let's think about the statement C and D also. Look at statement C. A photon of frequency 3.6 into 10 to the power minus 14 hertz has a lesser energy than so they have given frequency 3.6 into 10 to the power minus 14. That's one frequency. And the other one is, let's say lambda, nu1 and nu2. Nu2 is 1.8 into 10 to the power minus 14. So what you can see, you can compare these two values, and this is obviously higher. Okay, so if the frequency is high, you can see they are directly proportional. This one should have a higher energy than the second one. So is this statement correct? They are telling lesser energy, so this is going to be incorrect. Understood? Why? Because frequency is directly proportional to energy. Okay, and the next one, radiation whose energy per mole of photons is 820 is faster than the radiation whose energy 482. So they are giving you two energies. One value is 820, other one is 482. So this one is obviously having a higher energy. So they're asking whether this travel faster. No. Okay, if they are traveling in the same medium, okay, they must travel at the same speed. That's one of the point I described when I start the question. Remember, okay, so you can add any electromagnetic radiation, travel at the same speed given medium. So therefore telling that lesser speed, higher speed thing is wrong. Understood, Laman? So the wrong statements they're asking, incorrect ones. So answer is C and D. C and D is the answer 3. Okay, now look at the 13th one. Which of the following statements are correct regarding the ionization energy? Okay, so in the question it is asking to compare second ionizations, third ionizations, in addition to the first ionization energy. So I'll explain first ionization energy quickly. So there is a method that we get everything with the help of the graph, no? So we'll see what are the elements they are expecting us to know. Oxygen and fluorine. Okay, so here we have oxygen, here we have fluorine. And it is asking about this graph is for the first ionization energy. First ionization energy. Or in other words, we call IE1. Okay, so we can use this graph to compare second ionization energies and third ionization in anything, right? Because when we remove electrons, okay, it assume the electronic configuration of the earlier element. So if you want to compare second ionization energies, you just have to come one backward, isn't it? So the question first statement is asking the second ionization energies of oxygen and fluorine. Okay, so let's write it as O plus and F plus. So F plus comes to the place of oxygen. O plus comes to the place of nitrogen. Understand? So now you can see second ionization energy of oxygen is higher. Okay, so the statement is telling greater than fluorine element. So A is correct. A is correct. So we can explain a little bit about the second ionization. If you take gaseous oxygen atom and remove one electron to become O plus, it is our first ionization energy, IE1. Okay, and then you can remove another electron. Okay, for it to become O2 plus. Okay, so that will be IE2. So now you understand the reason why I said you have to come one backward. You have to know the logic, okay, behind that. Don't just say always you have to come one back. That is not the reason. I explained that in the class. Right? You have to tell, okay, what is the actual reason of coming one backward. Okay, the reason is this. After removing, now the configuration of oxygen is 1s2, 2s2, and 2p4. Okay, after removing one electron, it gets the electronic configuration 1s2, 2s2, and 2p3. 2p3 is a stable electronic configuration. That's why it is hard to remove the electron. Second point, second statement, third ionization enthalpy of phosphorus is greater than aluminium. Okay, so we have to find first of all where this phosphorus and aluminium is there. So phosphorus you can find in the third period. Aluminium you can find right here, the same third period. So third ionization energy, you have to come, 2 steps backward. For second ionization, you came 1 backward. For the third ionization, you have to come 2 backward. So that means you are going here and then you are coming right here. Okay. So aluminium 2 plus is right here. And this IE3, you are removing another electron for it to become aluminium 3 plus. Understood? This is IE3. Okay, then phosphorus, here 1 and there's the other one. Here P2 plus will be right here and aluminium 3 plus will be right here. Understood? So now you can compare the 2 positions. The third ionization enthalpy of phosphorus is greater. That one is correct. B is also correct. Okay, you can see still phosphorus is right here. But if you go to the fourth ionization energy, result will be changed. No? Can you see? If you go to the aluminium fourth ionization, it remove 1, 2, 3, and there you have fourth ionization. Okay, but IE4, that's a additionally you can add that point. IE4 of aluminium will be higher than IE4 of phosphorus. Why? Because IE4 of aluminium, the fourth ionization energy, electrons are removed from neon configuration, which is a very stable configuration. Okay, so but the question is asking about the third ionization, so answer is correct. Look at the next one. First ionization enthalpy of aluminium is slightly greater than gallium. Okay, so what is this gallium? Gallium, okay, Ga in the periodic table, you will find it right underneath aluminium. So they are in the same group 13, according to the levels. Okay, so what will happen to the ionization energy downward the group? IE1 decreases. Okay, so what is the reason for that? Why ionization energy, third one, ionization energy decreases downward the group? Because it's all explained with the nuclear attraction. We have to say what? Effective nuclear attraction decreases. Effective nuclear attraction decreases. That's why downward the group ionization energy decreases. So answer C is also correct. Understood? Answer C is also correct. So that means 3 answers are correct. Obviously, answer is going to be answer 5. Okay, there's no doubt here. But let's analyze the fourth statement also, D statement also. Okay, in the D statement, the second ionization energy, enthalpy of copper, is greater than that of zinc. Okay, so we didn't discuss copper zinc, but still you can select the answer 5. So second ionization, copper, you are removing from copper plus no, to become copper 2 plus. Then this is IE2 no. So copper plus will have 3D10 configuration. 3D10 configuration, but zinc plus will have what? 3D10 OS1 configuration. So now 3D10 is stable. So therefore, second ionization of copper will be higher. Okay, copper second ionization will be higher. So IE2 of copper is greater than IE2 of zinc. But if you take IE1 the other way around, okay, like I explained. Right, so all statements are correct. Answer is answer 5. For 14, which of the following statement or statements concerning electron are correct? So look at the statements. Electron tend to move in a curved path in a magnetic field. Okay, so electrons are moving in a curved path. Yes, that is true. So when you want to just answer these questions, you have to remind the theories about cathode rays and alpha beta gamma radiation. Then it will help you to understand these points. Okay, right. Let's see. Electrons tend to move in a curved path in a magnetic field. So that statement is true. Why? Okay, because what is the theory point we learn for that? not only for the electrons. We have a golden statement for any sort of a particle. What is the statement? Any charged particle, okay, any charged particle is deflecting or changing its path in a magnetic field and in an electrical field. Okay, so the deflection happens in an electrical field, it deflects towards the positive or negative pole, but in a magnetic field it deflects perpendicular to the magnetic field, because we know this one, Fleming's left hand rule. You can apply and you can see the electrical field forces, they all are perpendicular to each other. Okay, so that's why whatever the charged particle deflecting perpendicular to the magnetic. Okay, so like that, just remind that point. Okay, which is a, that's why I told you it's a very famous and popular question point. So A is correct. Why? Okay, because any charged particle deflects in electrical and magnetic fields. Understood? Electrical and magnetic fields. Okay, so then B, electrons have both particles and wave properties. It's also correct. Why? Both particle and wave properties, that is true. Okay, because any particle, basically any particle have this wave and particle both characters. We call it as dual behavior. So we can use that de Broglie equation to nicely explain this. Lambda de Broglie wavelength equal h over mv. So lambda right here is a wave character. Okay, wave character. mv is what? Momentum. It is a particle character. You can see wave properties and particle properties are related in the same equation. So this is a simple way of explaining this. Actual explanation is a long one, but still we can get some rough idea. Okay, so these two are related. So whatever the particle that show wave character should, whatever the particle that show particle properties must show wave properties. But those wave properties will be dominant if the particle is very small, just like electrons. Okay, so for example, I explained you in the theory class, if it is a particle like baseball, it's a somewhat heavy and large object relative to electron, it will also have a wavelength, but it is a very small value. Even it's a negligible value. That's why. Okay, so you're not going to worry about the wavelengths of those macroscopic particles. We only worry about the wavelengths of these tiny microscopic, electron like particles. Okay, wavelength of neutron, electron, proton, atoms. Okay, those particles, alpha particles, like that, that's the only discussion we have. Okay, so those are having wave and particle both characters. Statement C, look at that. Electrons cannot be added or removed from an atom. So that's a kind of a silly statement. You know that we can add and remove electrons. Let's say let's take sodium. You want to remove electrons, you can do it, no issue. So then you will form a cation by removing electrons. Let's take Cl minus Cl. If you give an electron to that, you can form anions like that. So electron adding and removing both can happen. So you can do both things to the same atom also. So here I gave electron to chlorine. I can remove an electron from chlorine also to make it Cl plus. Understood? I can remove an electron also. No issue. Right? So like that, C statement is wrong because we can remove and add electron. Look at D. The speed of electron is equal to the speed of light. That's also wrong. Why? Because electron is a particle. Okay, any particle travel at a lower speed than speed of light. Speed of light symbol is c. No? Okay, so remember beta particles are traveling up to 0.99 c. That's the maximum speed. Beta particles are equivalent to electrons, no? So therefore this is wrong. Okay, nothing can travel at the speed of light. Only photons or energy packets travel at the speed of light. Travel at the speed of light at 3 into 10 to the power 8 meters per second. So the answer for that question is what? The correct ones are A and B, no? Answer is 1. Answer is 1. Then go to the question number 15. It's asking again about alpha, beta, gamma radiation. Incorrect ones. Okay, so be careful. Be careful. Get the question. When alpha rays are radiated towards a thin gold foil, majority of the particles passes through the foil with no deflection. Okay, so this is the theory. You can write down in your paper. It is gold foil experiment. So who conducted the gold foil experiment? Geiger and Marsden, under the guidance of what? Who? Rutherford. Okay, so Rutherford, Geiger, Marsden, those are the 3 scientists who conducted the gold foil experiment. So in that experiment, they, radiated, okay, alpha particles towards a thin gold foil. Okay, so actually, like it is the statement telling, most of the alpha particles pass through the foil without any deflection. Okay, so there are 3 observations in the gold foil experiment. First one, majority of the particles pass through without any deflection. Second one, a few number of particles were deflected with small angles. Okay, and the third observation, very few number of particles were bounced back. This is your gold foil. Just put a diagram, small one will be enough. When you are sending alpha particles, majority of the alpha particles are passing through that, and very few are deflecting in small angles, and very few are bouncing back. Okay, right, these are the observations, right? So A is correct. What about B? B is telling James Chadwick discovered the neutron by radiating alpha particles at a target of beryllium. Chadwick is the one who discovered neutron. You have to pay attention to the each detail. Okay, sometimes they might give the incorrect name of the scientist, right? James Chadwick is the one who discovered neutron, and it is done by radiating alpha particles at a target of beryllium. Beryllium, in addition to that, he used boron element also. He used 2 elements, beryllium and boron. Okay, so that is statement is also correct. Okay, so beryllium and boron were used. And the first one, we can say something why the majority of the particles pass through the without any deflection, because most of the space of the atom, is empty. Okay, you have a small central nucleus. That's the only thing that's there. Okay, because when they hit or when they pass near a nuclei, they will be deflect or bounce back. Okay, just go through our previous recordings. You can just remind this in a nice way. Okay, what about statement C? Alpha rays can penetrate through matter easily than beta rays. That's totally wrong, right? So who has a higher penetration ability is minimum for alpha. Then you have a good penetration power for beta, and the highest penetration power will be there for gamma, which are electromagnetic radiation. Okay, as the size decreases, penetration power increase. Understood that? So therefore, telling that alpha is having a higher penetration power is totally wrong. Okay, and then check the D. E over M ratio of anode rays does not depend on the type of gas. Okay, no, it is depending on the type of the gas. Okay, so what is this E over M ratio? E over M ratio. Okay, so that you saw that E over M ratio first for the cathode rays. E stands for charge and M stands for the mass. We can say in short, charge over mass ratios, right? To take it for cathode rays, charge over mass ratio is constant. It is constant for cathode rays. Constant for cathode rays. Why? Because cathode rays are always electrons. No, it's a single particle. So E over M ratio is a constant value for the cathode. But if you take E over M ratio for the anode rays, okay, so it will be different for anode rays. Why? Because anode rays are depending on the type of gas. If you had hydrogen gas, anode ray particle will be H plus. If you had a different gas, let's say helium, it will be helium plus. So you know the masses are different. Sun has a higher mass, so therefore obviously the EOM ratio will be lower. So anode rays will have different E over M ratios depending on the type of gas. So that this statement is clearly wrong. Okay. So again, the question is asking the incorrect ones. No? So B and C and D are incorrect. Again, therefore, answer is answer 3. Answer 3. Now let's see the next one. Question number 16. Out of the diagram indicated below, which diagram is correct regarding the Hund's principle, Hund's rule? See the configurations. According to the Hund's rule, you know that energy levels, the electrons should be filled in, okay, same direction spin. So you had only worry about the 2p3 configuration. So how this 2p3 should be given? Okay, there are few options you have. 2p3 you can put it like this, as they are having the same spin, or you can put them in the anticlockwise spin also. So both these arrangements are correct. But if it is there in the, the one upward and others are downward, then it is wrong. So if you fill 2 electrons to the same orbital, then it is also wrong. Understand? So just remind. So electrons are filled. Okay, you can write the Hund's rule from your note here. Then it will be nicely explained. Okay. First, electrons are filled singly as the spins are parallel. Then they will be paired. So then the answer is what, Lamai? Here the A is correct and D is correct. A, D answer 4. Most of you had done this question well, okay? Yeah, then go to the last 4 MCQs, which are coming from false type question. True false type question. Okay, look at that. The densities of water and D2O are equal, while H2O and D2O are equal, while H2O and D2O show different chemical reactions with the sodium metal. So that is wrong. Why? Because Lamai, isotopes, no? So oxygen isotopes, so hydrogen, deuterium, those are isotopes of same element, hydrogen. These are isotopes. So isotopes are having similar chemical properties. Okay, and those will have different physical properties. Isotopes will have similar chemical properties and different physical properties. Why their chemical properties are same? Because they share the same electronic configuration. Okay, so hydrogen, whatever the isotope, okay, so they must have the same chemical properties. Okay, because water and D2O should react in the same way with sodium. There should be no difference. Okay, so let's say sodium with water, it will give you sodium hydroxide and H2. Okay, then sodium with D2O should also give the same result, NaOD and D2. Understood, Lama? So it should be the same reaction. Isotope. That's not different. Even though we put a different letter, it doesn't mean it's a different compound. It's the same thing. Same hydrogen, deuterium, with one proton and one neutron. Okay. H10, H11 and D12. That's how we write. No, there's a thing called tritium also. H. You can write H also. H13. First one is also incorrect. Second one is also incorrect. So answer is going to be answer 5. Both are incorrect. Okay. Physical properties and chemical properties are different from each other. Then look at the question number 18. It's about de Broglie wavelength. The de Broglie wavelength of helium and neon are the same when the speed of gaseous atoms helium and neon are equal. About the de Broglie wavelength. Let's see that one. You have lambda equal h over mv. Okay, de Broglie wavelength of helium and neon. Okay, so when their speeds are equal, lambda is inversely proportional to the mass. No? So helium is obviously having a lower mass than neon. So as the mass decreases for helium, its de Broglie wavelength should be higher. Like I said earlier, electrons are having a considerable de Broglie wavelength than a golf ball. Okay, so the same thing here. They're asking if helium de Broglie wavelength and neon de Broglie wavelengths are same. They're asking when the speed of gaseous atoms, helium and neon are equal. So even though the speeds are equal, their masses are different. Therefore, the de Broglie wavelength must be changed like this. Like I said, so lambda helium should be higher than the lambda neon if they are traveling at the same speed. Okay, so therefore the first statement is false. Understood that? Okay, right. And the next one, the de Broglie wavelength of a given moving particle is inversely proportional to its speed. So the given moving particle is very important, Lamai. Given moving particle, highlight that one. Because given moving particle, that phrase indicate that mass is constant. Without telling mass is constant, this statement is wrong. Understand that? Huh? Those are really important statements. Okay. So if they just say de Broglie wavelength is inversely proportional to they are telling the speed, no, that is wrong. Okay, so if they says, I'll write that statement also. Lambda is inversely proportional. If they just give this statement, then that is wrong. Understand? Then that is wrong. Why? Because they are not mentioning about the mass. Mass should be constant in order to this to be true. Is that clear? So it's applicable for any formula. Okay, any formula. You have to mention about the mass of the particle. Okay, because according to the de Broglie equation, only if this one is constant, this relationship will be true. Okay, so anyway, the second statement is true, but first one was wrong. Therefore, answer is answer 4. Answer is answer 4. Yeah, now look at the 19th question. First ionization energy value of oxygen has a value between first ionization energies of carbon and nitrogen. Carbon and nitrogen. Okay, first ionization energy of oxygen. This is where the oxygen lies, and nitrogen, and here you have carbon. And other elements are here. So that is true, no? Oxygen has an in-between value. Why? Because nitrogen ionization energy is higher than expected because of its 2s2 2p3 stable electronic configuration. Understand? So listen to this statement I'm going to say. Okay, ionization energy increases across the period from left to right. Okay, ionization energy increases across the period from left to right. Okay. According to that, that the reason is the increasing nuclear attraction, because nuclear attraction increases across the period. Therefore, it should be difficult to remove electrons. Okay, so according to that point, oxygen ionization energy should be higher than nitrogen, but it actually doesn't happen. Why? Because nitrogen has another factor that is helping to make its electronic configuration, a stable one. That stable configuration, according to Hund's rule, if electrons are, the filling one per each orbital. Okay, so in that arrangement gives a stability, an extra stability for the nitrogen. Because of that, removing electrons is now extra difficult. Okay, so that's why nitrogen has a higher ionization energy than oxygen. Okay, so when you are explaining, they might give a MCQ like this. Okay, they might tell what are the factors affecting ionization energy. Don't just say effective nuclear attraction. Okay, electronic configuration is also affecting on that. So anyway, first statement is true. So like I explained, now when you are getting a true statement, think about the reason why this is true. Why this is true? Because of the nitrogen electronic configuration. Okay, so they have to say something regarding the configuration. Okay, but look at the second statement. The covalent radii of oxygen lie between the carbon and iron. That is totally wrong. Why? Because radius always decreases across the period. So there is no zigzag variation for the radius. Okay, across the period. That's going to be wrong. Understood that? So answer is going to be answer 3. Answer 3. First one true, second one false. Right? We go to the last question. 20th one. The direction of the increasing frequency, that's from the emission spectrum. Okay, spacing between the spectral lines of H emission spectrum decreases rapidly. So like I said, Lamai, I'll explain this emission spectrum again in your structured essay paper discussion. Okay, so until that, just I'm going to tell you a brief overview regarding the question. Okay, if you take the emission spectrum, this is what we call as the spectrum. Okay, they are not the arrows we draw in the energy level. That is something else. That's not the spectrum. So this one is having smaller gaps. This one is having larger gaps. So if this is Balmer, this should be what? Should be Lyman, because towards this direction, energy increases. Frequency is proportional to energy, no? So therefore, that also increases. And wavelength decreases. Okay, so towards increasing direction of the energy, frequency, okay, spacing decrease rapidly. Yes, here the spacing is X, here the spacing is Y, like that. Spacing decreases rapidly. That statement is correct. And the reason for that is why, like I said earlier, if it is true, think about the reason why it is happening. Okay, then you can check whether that is the reason you thought, whether it is there in the second state. Okay, first of all, think a reason. Why? Because energy levels are, the gap between energy levels decreasing rapidly. That's why the gap between energy levels, gap between the spacing between the emission spectrum lines also decreases. Yeah, this should be it. Okay, first one, second one, third one. Now look at this. First one and second one, you have a higher gap, but second one and third one, you have a lower gap. Therefore, when you are drawing them, it will be like this: 1, 2, 3. There's a higher gap and there is a lower gap. See, so you have to mention about the energy level, energy difference, energy level. Okay, so look at this. Explain the second point they gave. When moving away from the nucleus of the atom, energy gap between the energy levels decreases rapidly. So like I said, energy gap decreases. Okay, so remember a nice to know theory point I told you. If the first energy level and second energy level energy is E, the second one and infinite one, let's say this is infinite, second one and infinite energy will be E by 3. So that's the explanation for the our unit test MCQs, and we will discuss now. I have some time left. Okay, I'm going to take few minutes from your time. Past paper structured is a Lewis structures. Okay, so I have our tutor with me today. Right. So shall we discuss those past paper questions? I have 2019 question. It is SO3F2 in 2019 11. This is the new syllabus first paper. SO3F2, and they gave, now just think about this one, Lama. Our first thing is to drawing a skeleton structure, no? But if it is atomic composition like this, straight away drawing the skeleton structure may be confusing. Okay, so therefore in that case they will give you a skeleton. Okay, so they have given you one right here, SOFO, yeah, like this. Okay, so now let's see what is the method. First one, so I'm going to explain at the end the fast method also, so just wait, right? See, let's go through the Lewis structure normal method I taught you during the class. Okay, first of all we have to find out how many valence electrons are there. From sulfur you have 6 valence electrons. So how 6 came? Because sulfur is in the group 16. Okay, so it has 6 valence electrons. You can quickly take that valence electron count by looking at the group number, or you can write the electronic configuration also, but it will take time. The best way is looking at the group number and taking the valence electrons. Okay, you have 6 valence electrons from sulfur, and then take oxygen. Oxygen is also in the same group, so there will be another 6 electrons. We have 3 oxygen atoms, so 3 into 6. Then you have 2 fluorine atoms. Fluorine is in the group 17, so 7 valence electrons. Means there are 2 fluorine atoms, 7 into 2. There are no charges, so if there was a charge or something, you have to add those subtract electrons. Okay, right? So 6, 18, and 14. You have 38 electrons. Okay, from that 38, we already have represented some of the electrons. So our purpose of drawing Lewis structure, we are going to represent how these electrons are there. That's our target. Just imagine water molecule. We are representing it like this. So in this structure, we have represented how many electrons? We have represented 8 electrons. Here you have 2, 4, 6, and 8. Each bond is a 2 electron. So how many valence electrons were there for the oxygen? 6, and for the hydrogen there were 1 into 2. So altogether you have 8 valence electrons. So actually what we did is we represented how these 8 electrons are there in water molecule. That's our purpose, target. Understand? So here also we are going to do the same thing. I'm going to show how these 38 electrons are there in the structure of this SO3F2. Okay, so that's the thing. So already we have represented some of the electrons. No? 1, 2, 3, 4, 5. So in 5 bonds we have represented 10 electrons. You have to subtract that. Then you get the 28, and then convert that 28 into electron pairs. So we have how many? 14 electron pairs. So distribute those 14 electron pairs starting from the most electronegative peripheral atom, which is fluorine here. Okay, so 3, 6, 9, 12. There are 2 more, so I can put them to the next one, oxygen. So why did I put 3 pairs? Because I explained that one in the class. I'm going to tell again. Anyway, the reason is putting the 6 electrons here just to complete the octet. Okay, so already shared 2 electrons now, so it needs 6 more electrons to complete the 8th electron. So why 8? Because our main, actually why atoms are making bonds, just to have a stable electronic configuration, okay. So 8 is the stable electronic configuration they can have. Understood? So therefore, we have to put 8 electrons until it achieve its octet. Okay, 8 electrons. Right. So what is the next step? Then we have to check for whether the octet is completed or not. Okay. So now if you see all these atoms, they are having complete octet. You check oxygen also, 1, 2, 3, 4, 4, and there are 2 bonds also. So 8 electrons are completed. Even for the sulfur, it has 4 bonds. That means octet is okay. So our next thing is, after checking the octet whether it is complete or not, you have to check for the charge. Charge of this oxygen is -1. This one is also -1. So how do we check the charge? We are checking it like this. Okay. So oxygen brought 6 electrons, right? So how many electrons are now there with this oxygen? 1, 2, 3, 4, 5, 6, and there is one more electron from the bond. So oxygen now, its own electrons are there, 7 electrons, but it only brought 6. No? So you can see one oxygen brought only 6 electrons. So therefore, this is having one extra electron. That's what we are adding as minus charge. Okay. So in the same way, you can see sulfur will have a +2 charge, because if you check again, sulfur, its own electrons are there 4, because from these bonds I have represented one electron is from oxygen and the other one is from sulfur. See, sulfur is having only 4 electrons is shown there, but it brought 6 of them. So 2 is missing. That's why we are putting +2. Okay. So like that, our next option is to minimize this charge. If possible, we have to minimize the charge. Sulfur can make more than 4 bonds. Sulfur can violate the octet. Okay, because sulfur has a third energy level. In third energy level, you can keep more than 8 electrons. Okay, so therefore, if possible, we need to make the charge minimum. So now then you might think, okay, now the octet is exceeding, whether that will be stable. Yes, it is stable. Why? Because rather than having charges, sulfur like to have a neutral state. That's why it is more stable. So therefore, it will make 2 bonds with these oxygen atoms and complete it, achieve the minimum charge state. Minimum charge state. Okay. So this will be the Lewis structure. Understood? So if you have drawn this correctly, mark it. Okay. That's for the 2019 A-level paper. And shall we try the 2022 one also? That's an interesting point to tell. I have an important point to tell you here. Okay? Yeah, so the molecule cyan actually, N2O3 2-. They gave the skeleton like this. So what should we do first? We have to add the number of total valence electrons. Okay. From nitrogen, you have 5 electrons and there are 2 nitrogen atoms now. So 10. Then oxygen, you have 6 valence electrons. 6 into 3, 80. And this is the one I was telling earlier, -2. -2 means there are extra electrons. So you have to add 2 more electrons to this. Extra electrons. So altogether you will have 20 and 30 total electrons. So from that 30 electrons, you already have represented 1, 2, 3, 4, 8 electrons here. Okay, so 4 bonds, 8 electrons. So you have 22 total electrons. Okay, from that 22, you haven't represent these 22. Okay, to represent them, what should you do? You have to first convert them into pairs. So that means 11 electron pairs are there. So then those place those 11 electron pairs here. Start with oxygen, and you'll be left with 2 pairs. So that's the point. When you distribute those 2 pairs, remember in these cases to add those 2 electron pairs, 1 per each nitrogen. Remember to do like that. So there will be several more cases like this. In each one, remember, if you have option like that, if it is the same element atom, give 1 per each. Okay, remember that. That's the special point here. Okay, so then you will get the correct structure, because they both are like basically the same way to the electron, and they both are central atoms. So giving both pairs to one atom is not going to be fair, right? Now our next thing is completing the octet. Octet of this one is not completed. To complete that, we have to make a double bond. Okay, so then I will have the structure like this. This lone pair is gone. Okay, there's no need to leave this empty. If you want, if you can place like this also, no problem, right? But anyway, I'm as a teacher, I should be uh, represent you the without any doubts, no? That's why I'm always writing like this. Okay, right. And here you are having this. Now the octets are completed for each element. Okay, then we have to check for the charges. Here you have a -1 charge, -1 charge, and that's our Lewis structure. That's our structure. Okay, what if you put the both lone pairs to one atom? That also we have to discuss. If you put both lone pairs to one nitrogen atom, the one in the right, you can put both lone pairs there. Okay, look at this one. What happens? If you put 2 lone pairs like this, then octet of this one will not be completed. Then you have to fill the octet like this. Some of you might have tried this also. Okay, check what happens. Okay, so then you will have a structure like this. Negative charge will be right here, and there will be another negative charge here. There will be another negative charge here. There's 1, 2, 3, 4, 5, 6 more electron is there, and there will be a plus charge here. Here you have a higher charge separation. Remember last week I told you, if the charge separation is high, then that structure is going to be unstable. That's why I advise to put the electron pairs to both nitrogen atoms, 1 per each. And this is stable, minimum charge separation. Minimum charge separation. You can't avoid -2 charges, okay? It must be there, no? But it is having the minimum charge separation. That's why it is stable, it is good. 2021 A-level. Cl2O4. Now look at the short method. So what is meant by that? First of all, we need the skeleton structure. Okay. So now it is not having any charge. Now look at the things. Okay, you need some practice for this. Okay. So here you don't have any charge. No overall charge. And then you can see the central atoms are, one of the central atom is chlorine. Okay, central atom chlorine exists. So if chlorine is there as a central atom, with practice it exceeds the octet. Exceed the octet. Exceed the octet. And then one more thing, right? And with the practice, if oxygen is there like a peripheral atom, there are only 2 options that can be there. Either it can have a double bond with no charge, or it can have a single bond with a negative charge. These are the 2 options for oxygen. With the practice, you have seen that. You have both cases right here. Okay. So now if chlorine can exceed the octet and oxygen can achieve like this state, no? So this is the most suitable state for this molecule. You decide that one with your practice. Okay, remember that. Okay, with your practice. Okay, so then you can easily put 3 double bonds here with 2 lone pairs for each oxygen. Okay, and then you decide on this oxygen also. This is the central oxygen, just like water molecule. Remember, this everything is coming from the practice. Okay, Lama? It's like the water molecule. It's like the water molecule. So we draw water molecule this today like this. This is the water molecule. So it's a similar one, no? Similar arrangement. It should be like this. And if halogens are as the peripheral atoms, that's another point. If halogens are the peripheral atoms, if halogens come as peripheral atoms, okay, it will be always make a single bond. Understand? It will always make a single bond like this, having 3 lone pairs. So this must be the structure. Understand? So without going through the Lewis method, with your practice, you can draw structures like this. Okay, but I'm not recommending this one right away. If you have enough practice, so let's say you have drawn at least 30-40 structures with me now. I gave some homeworks and we did 12-13 structures in the class also. If you are okay now, you yourself will understand whether I can try this or not. Understand? So if you're having any doubt, any issue, right away go to the basic method. I also myself do that. Okay, let's say when doing a question, I'm somewhat, there's a chance of getting stuck in. No, if I get stuck in, then I'll right away go to this method. Then try, then I get the correct one. But the thing is, it takes some time. No? So you can save that time in A-level exam. Okay, it have much time to left. Huh? So in that exam, we can try short methods. Okay. So with the practice, eventually you will come there. Okay. I just want to show you how to do that. Everything is coming with the practice. No. If there is no central charge, if there is a central chlorine, it exceeds the octet. These are the options for the oxygen, and we have to select this because the central atom is chlorine. No? Then if there are peripheral halogens, they make a single bond with 3 lone pairs like that. This is all practice. And this is also practice. Water molecule, you remind water molecule here. Like okay, with the practice, you can try. Okay, so anyway, in A-level exam, they are giving marks for only the final structure. They are not giving marks for the steps. Get the idea? Okay, so steps are there to make sure that you write it okay, right? We'll see. Right. So what did we discuss today? So we had a very, I think, very good discussion, very clear discussion about the last 10 MCQs in our unit test exam, unit test paper. And you have to write a good review for the whole 20 MCQ and bring it to the class with you when you are coming. So I hope every doubt is clear. You can ask further, send a message, or at least ask them in the class. Okay. Right. So, Lamai, good night. Study well. See you again in the next class.